All right, last couple questions from 2014 for today. And so this should be Wednesday of the first week of daily FRQs. You got 6 and 7. So this is number 6 off 2014's exam. Student places a mixture of plastic beads. One has this polypropylene and the other is polyvinyl chloride. This is where my kids came in at the end of the year and said, the whole test is organic. There's nothing organic in this question other than these structures are organic structures. So don't panic. Just trust your training. Figure it out. It says we stir the 2 sets of beads into a beaker, and one of the beads sinks and the other floats. Gives us the structures, and it says given the spacing between the polymer chains, the beads that sink are made of which polymer. And so they take up the same amount of space. One of them is going to sink. This is a simple density formula type question where density equals mass over volume, and these guys both have the same volume because their spacing is the same. So which one's going to have the higher density and sink? The one that has the greater mass. And so greater mass per same volume. So they kind of give us parentheses of these repeating chains, these polymers. And so here's how I wrote it. PVC sinks because the spacing or volume is similar, but the chlorine has a bigger mass than the CH3 that's attached. Therefore, PVC is more dense. If you want to write the density formula in there as part of your justification, I think that's a valid thing to do. Good, that's it. It's worth a point. Then part B says you've got a couple other organic things. This is how they make this polypropylene. And so we use propene, and then the PVC is synthesized from C2H3Cl. The structure of the molecules are shown here. One is propene, one is vinyl chloride. And ask us a question. The boiling point of the liquid propene, the one on the left, is lower than the boiling point of the vinyl on the right. Account for this difference in terms of types and strength of intermolecular forces in each one of these liquids. So you've got to talk about the intermolecular forces in each of these. So both of them and every molecule is going to have dispersion forces because they have movement of electrons. So you should say they both have dispersion forces. They both have some dipole forces here. That chlorine is causing the vinyl chloride to be polar. The truth is the difference in that double bond causing the bond length to shrink versus that single bond also creates some polarity in this one. And so we've got to talk about which one of those is going to have the bigger dipole moment. And when we look at this, so write it down, both substances have dispersion forces and dipole forces. The chlorine in the vinyl chloride has more electrons than the CH3 has in the propene. And because it has more electrons, it is going to have more polarizability, or it's going to be more polarizable, giving it a greater dipole moment and a higher boiling point. That's how you would word part B on number 6. And then the last one here is a Hess's Law problem. I know they're taking the some of the entropy stuff off of the exam, but I'm guessing they're not going to be taking any of the enthalpy stuff off the exam. I would guess you'll have some enthalpy questions. This is an awfully long FRQ when they're talking about a 45-minute test as far as Hess's Law question goes, but we definitely need to understand it conceptually and be able to do it quick in a multiple choice question. So part C here says using the table of standard enthalpies. We'll start here. It says in a separate experiment, student measures enthalpies of combustion of propene and vinyl chloride. And so this first one is the vinyl chloride. It says 2 moles of it, so that 2, be aware of coefficients, 2 moles of it are going to release 2,300 kilojoules of energy. Fantastic. Hopefully you can see that. It says using the standard enthalpies of formation below, determine whether the combustion of 2 moles of propene releases more or less or the same amount of 2 moles of vinyl chloride releases. And so we want to know that using this equation, are we going to produce more or less energy or release more or less energy than that negative 2,300 And so here we go, they give us a chart. This is a Hess's law problem. These are enthalpies. Enthalpies delta H for the reaction is going to be equal to delta H of products minus delta H of reactants. I encourage the good form here. And so the delta H of this reaction is going to be equal to sum of the products. Here we have 6 carbon dioxides plus 6 waters. Be careful of the states of matter here. Sometimes they'll give you a water down here as a liquid and a water as a gas, and so be careful there because there's a difference. And those products minus the reactants, we've got 2 of the C3H6s plus 9 of those oxygens. One of the things you'll remember back from when we went over Hess's law early in the year in chapter 6 is that pure elements don't have any heats of formation. We talk about God made those, so we don't know how much energy he put into those things. So this guy, oxygen, there will be a 0, which is nice. We won't have to put the values in for it. And so then plug your values in. CO2 is negative 394 kilojoules plus 6 times the water is negative 242 kilojoules, all minus 2 times the 21 for the C6H6. And when you plug all those in, and I encourage you plug it in, don't take my word for it, plug it in just so you can make sure you're careful of signs here. We've got a lot of negatives here, subtracting some positives, so this should be a big negative, and it is. It's negative 3858 kilojoules coming out of this reaction. It's nice, be careful, it's nice, this was 2 moles up here, and this one is also 2 moles of the propene, and so it's nice that those are comparable to each other when they can say compare 2 moles of each. Just be careful of the stoichiometry there. Answer the question. That's our answer, right, to the delta H. We need to answer the question. The question says, will the propene release more, less, or the same amount of energy? So the propene will release more energy. Answer the question. Make sure you answer the question. You get 1 point for the value here, and you get 1 point for saying propene will release more energy. If for some reason you got a smaller value here and you said propene will release less energy, then you still get that point due to propagation error. But those are your 2 points in question number 6. Talk to you soon. Bye.